So welcome to this series for Electronics for Computing 2. In this video, I'll be introducing what Electronics for Computing 2 is. Okay, so let's go over the definition of what electronics is. So by definition, what is electronics? Electronics is a branch, okay, a branch of science, and engineering that focuses on electronic, okay, on electronic programmable devices or machines that do what? That perform high-speed mathematical and logic operations to process information. Okay, so electronics does not change from electronics 1. So electronics is just simply a branch of science and engineering that focuses on electronic programmable devices or machines that perform high-speed mathematical and logic operations to process information. Okay, so Electronics for Computing 2 is a continuation of Electronics for Computing 1. So by the time that you're coming to this series, you must have covered, okay, all the topics, okay, all the topics in Electronics for Computing 1. Okay, you must have done that. If you have not done Electronics for Computing 1, you're going to find a link to my series that covers all the topics in Electronics for Computing 1 by the time you'll be watching this video. Then Electronics for Computing 2, as a continuation for Electronics for Computing 1, we're going to carry on from where we left off in Electronics for Computing 1. So what is it that we're going to be looking at in Electronics for Computing 2? So Electronics for Computing 2 is going to focus on combinational logic gates. We're going to focus on combinational logic gates and circuits. Okay, so in Electronics for Computing 1, you focused on learning about logic gates, OR gates, AND gates. You learned about all the independent gates and their truth tables, and also their operations, the Boolean equations, and also simplifying Boolean equations. But in Electronics for Computing 2, we're going to be studying gates that are made from a combination of individual logic gates. We're going to be studying circuits or combination of circuits that are made up or developed from a combination of circuits. So the same way that you learned an AND gate, for example, you have an AND gate and another AND gate. I'll extend two signals from here. I'll call this one signal A, this one signal B. So let's say a signal A, right, runs into that AND gate, and the signal B runs into that AND gate. Another signal A runs into this AND gate, another signal runs into this one. Then these two signals are running into an OR gate, like this. Then the output is called what? X. So when you have an interconnection of individual logic gates like this, they don't have to be the same. Here you can have an AND gate, you can have an AND gate and another OR gate. We can have a pair, even 30 AND gates or 32 OR gates, or a combination of AND gates, OR gates, and exclusive OR gates. It doesn't matter. But for as long as gates are interconnected, you come up with what is known as a combinational circuit or a combinational gate. So in Electronics for Computing 2, we're going to be focusing on combination what? Logic gates or combinational circuits, which means it's an interconnection of individual logic gates. So what are the topics that are going to cover in this course? One, we're going to talk about all the types of combinational circuit. We're going to talk about combinational logic gates. Okay, after combinational logic gates, we're also going to look at the concept of an op amp or operational amplifier. Op amp. So there's nothing here. So we're going to look at an op amp, operator or operation operator, operational amplifier. 3, we're going to look at concept of sequential circuits. Okay, from sequential circuits, we're going to look at the concept of counters. And 5, we're going to look at the concept of registers. Okay, these are the 5 major topics that we're going to look at in what electronics for computing too. So what are we actually looking at in these topics? These topics will be studying different circuits, we'll be studying their truth tables. Okay, we'll be studying their drawbacks. From their drawbacks, also after their drawbacks, we'll study their improvements. We'll study their usage or application. Yes. So we might have more detail than I've mentioned in what you're studying. So you study the circuit, you study its truth table, you study sometimes Boolean expressions, you study its drawbacks, you study its improvements, you study its usage. So just be going to be looking at different types of circuits, different types of combinational logic gates and circuits. We're going to look at op amps. We're going to look at sequential circuits. We're going to talk about counters. We're going to talk about what registers. So this is what we're going to cover in what electronics for computing.